Hello. I just wanted to give you all a quick introduction to the AI supported continuous integration testing project and hopefully give you enough information to get started yourself. This is a project that is currently being kicked off and developed by myself and members of the AI Center of Excellence, specifically the AIOps team here at Red Hat. And the main goal of this project is really to develop AI tools for developers by leveraging the open data made available by OpenShift and Kubernetes CI platforms. In short, operations data is far and few between in the open data world right now. And having access to these open data sets is a good boon for us and a good place to get started. So, what I'm going to talk about today quickly is just kind of the very first active project that we're working on, was essentially some data access and data management for a specific CI tool called TestGrid. So, I'm not sure if anyone here is familiar with TestGrid, but in short, it is a open source project developed by Google to help people kind of visualize their CI processes in a grid. And it's used by a number of people. Here's this dashboard here: Canonical, Gardner, Google, as well as Red Hat, obviously. And that is where we will focus today. So let me just go. We can click on Red Hat, and let's go ahead and find a specific board that's of interest to us. So as you can see up top, there's a number of different tabs for each of the different releases of OpenShift. And then it's divided into informing, blocking, or broken. And that's essentially just some different kind of test suites that are being used. So if you go to 4.6 informing, we can see that there are a number of different testing platforms that are used. We have some for testing release master end to end on AWS, some for bare metal, others for Azure. And each one based on is giving a signal of whether it's passing, failing, or flaky. And cool, so it's rather high level. But the thing that we're particularly interested in is one step further down, which are the actual test grids themselves. So what you're seeing here is the test grid for periodic CI OpenShift release master, OCP 4.6, AWS proxy. And what we have is kind of a higher order signal of once a developer makes a commit to OpenShift, it starts to go through this continuous integration process, gets built and tested, and then the results of that test are displayed here. And so what you're seeing is really whether or not it passed, whether or not it failed, and what the different tests that it did pass and fail are. So on the kind of the columns, right, are time periods, and the horizontal rows are the different tests. So as you can see, it's really just like a 2D array that we can do some analysis on as data scientists, and that's what we're going to do here. The problem we have right now is this data obviously is on this website and it's not in a data frame or a NumPy array for us to analyze directly. So what we're going to talk about now is how we go about doing that. And so that's what we've done here. If you go to our Operate First Jupyter Hub, there is a specific image that you can deploy called OCP CI Analysis that will have this repository that you can start to run instantly. Inside it, there's a set of notebooks. Right now, we're going to be looking at the a number of different data sources. TestGrid is the one that we're obviously interested in now, and then just doing that initial EDA. So that can be found in this notebook here. Cool, so I'll go through this rather quickly, but the idea is that you can go ahead and actually just restart and run all. And if you're on the deployed image, or you download the repository and use the pip file to install all the necessary dependencies, it should just run and download a data set for you to start to manipulate and explore. But just to give you a quick summary of how we actually did that, I'll just scroll down here. So the first thing we do is use requests to actually get the HTML of a specific page. To get the names of all of the different pages, which we will actually use to kind of programmatically later on grab all of the particular or all of the grids of interest to us. But the thing that you would want to look at, if you're interested in a particular grid that you want to analyze, you can come down here to cell 10 and actually put in the specific tab and grid name of interest to you, and changing that here will then go ahead and download the appropriate data. The other thing to note is that there is much more data available to us than just what's displayed on the grid. That's shown in these kind of metadata column names, I guess, or category names that you have here. So we haven't gone deeply into these yet, just for kind of sake of simplicity and getting started, but there is definitely some good, valuable information here that next steps should be to be looking into. However, for now, we're looking purely at the tests column, which actually has that information that we want to visualize. That's the grids themselves, right? So cool. So as you can see here, there's an output of that data. The first sticking point that we see here is that it is run length encoded, which is great for kind of compression, but it's not as useful for our particular needs. So the first thing we do is go ahead and kind of unroll it. And then that gives us, again, the raw values that we have. So now we have a data frame with the columns as tests, the rows as test, and in one of the columns we have the time series value for each of the tests of interest to us. And one thing you might notice here is the numbers are kind of odd with 12, 1. I don't know if any of these are 0. These are categorical values, right? So 1 represents pass, 0 represents not run, 12 represents failure, and there are some other ones in the middle there to be aware of. But for right now, we'll just be concerning ourselves really with not run, pass, and fail. Cool. So we can then go ahead and visualize this as a 2D array, and this is just to show that this particular pattern matches this pattern, so that what's being visualized on the website is in fact the data that we're getting access to. So that's good. So that's just a check that we've got the right thing. And then to do our due diligence, right, we want to make sure that we can just pull out a single row and look at it as a single time series instead of the 2D array. And that's displayed here. A quick example of looking at this particular symptom and seeing that it passed and is not run a number of times over its lifespan. Cool, so excellent. That is pretty much all that we want to show for this notebook. If you're interested in getting access to this data yourself, or not looking at a single dashboard, but the entire grid ecosystem, you can run this cell and it will download, it'll snake through all of the grids, download them, and store them in a easy to use JSON file where you just kind of navigate it through dashboard name and job name, and we'll bring up the particular grid of interest to you. Awesome. So I hope that was helpful and informative. There will be a follow-up video talking about some of the next steps where we actually dig into the analysis of this data. And yeah, looking forward to getting contributions and questions from others. Thank you.